Hi everyone, let's dive right in. So the first thing we're going to tackle is the situation where I give you some graph and you need to recognize and apply transformations to that graph. So in this situation, we're starting with this graph right here. This is our function g of x. So whenever we're asked to sketch something that involves g, we're referring back to this function right here. The first part is asking us to sketch y equals g of negative 2x. So our first job is going to be to recognize from the list on the last page what transformations we have, and then we'll have to work on applying them to the graph. So there are actually two transformations here. People look at that and they see we're multiplying x by negative 2 and they think that's just one thing. But when we're multiplying by a negative, we always separate that off. The multiplying by a negative is always some sort of reflection. And if there's a number other than 1 attached to that, then there's also some sort of stretch or compression. Since this is all inside the parentheses being applied to x, these are all horizontal transformations. So that negative sign is a flip of our x values, which we would call a flip or a reflect over the y-axis. Think carefully about that one. It's really easy to be able to visualize that in our head. So I'm kind of imagining it's sticking out this way. But not say it correctly because you're thinking x is flip, so you say x-axis. This is x is flip over the y-axis. The other thing happening is we're multiplying x's by 2, and remember these x transformations always happen the opposite of what you would think, because we're saying what would we have to do to get the same y value as before, and what that is actually the opposite of what you see there. So if you're seeing 2 times x, to get the same y value, you'll have to cut your x in half. So this is horizontal compression by a factor of 1/2, and you can just say by 1/2, but it really is a factor of 1/2. We're multiplying our x's by 1/2. Again, opposite of what it looks like, but that's what actually happens. Okay, so when we're applying these, we need to be able to follow some of the key points on this graph. So I'm going to follow the two endpoints. So this is at 2, 2, there's a closed circle. At 7, 2, there's an open circle. At 3, 4, there's a corner. And at 5, 4, there's another corner. So we need to flip all of these over the y-axis, which changes the sign of our x value. So here, if we're starting with the point AB, it will end up at negative AB. And then we need to apply horizontal compression, which cuts our x value in half. So here, if we're starting with AB, we'll end up with 1/2 AB. So we have to do both of those, and you can do them in either order. The only thing that's going to matter in terms of order is that you should always save your shifting for last. Everything else can happen in whatever order you want. It doesn't matter whether you do horizontal or vertical first, as long as stretch, compression, reflection happens first, and then shifting happens last. So it's kind of like order of operations. The multiplication, division stuff happens first, and the addition, subtraction stuff happens after that. Okay, so first step, I'm going to do this in orange and just kind of follow the points. We need to flip across the y-axis. So the point 2, 2 flips across the y-axis and ends up at negative 2, 2. You do not have to perfectly graph out every single step of transformations, but while you're getting started, I think it's probably a good idea to follow points really carefully. Next, let's look at the open circle that's at 7, 2. It's going to flip all the way across to negative 7, 2. So open circle at negative 7, 2. It's very important that you keep those closed circles closed and those open circles open so that I can see what landed where easily. The corner at 5, 4 ends up at negative 5, 4. And the corner at 3, 4 ends up at negative 3, 4. So just flipping straight across the axis. All right, and then if we want that whole thing sketched in, we can just connect the dots. This absolutely doesn't have to be dashed, but since it's one of my intermediate steps, I'm going to use that dashing to show that it's just kind of a temporary placeholder. So that was my step number 1. My step number 2 will be the horizontal compression by 1/2. So if I take the point -2, 2, I'm going to cut its x-coordinate in half, and it will move over to -1, 2. So I'm going to land at -1, 2. The open circle at -7, 2, when I cut x in half, will land at -3.5, 2. And then the corners, -3, 4 ends up at -1.5, 4. And -5, 4 ends up at -2.5, 4. So make sure that you label at least a couple of points. I would say 2, probably 3 points. After that, you don't have to label absolutely everything. So I'm going to label the -1.54, and I think that makes it pretty clear what's happening. So my final graph is this one. If you're going to draw multiple steps on a single grid, just make sure that it's very clear to me which one is your final answer. Or you could even like erase this orange graph now that we're done, do it off to the side on a separate graph. What I want to know is exactly what is your final graph, and sometimes when people draw multiple steps, I can't tell which one they think is the last answer. So that is the sketch of this new function, which is g but flipped over the y-axis and compressed horizontally. All right, let's do another one with the same function. So this is g of x plus 3 minus 1. You won't always have the original function right on the grid. I just did that for the videos because I didn't know if I could fit everything in one window otherwise. So if you don't, but you like it there, go ahead and just lightly sketch it in. And again, just make sure I know what your final graph is. All right, so when I'm looking at this one, we'll use the same colors for steps. I see x plus 3 in the parentheses. So I'm adding 3 to my x's, which is a horizontal transformation, and adding or subtracting is always a shift. So that is a shift by 3, but be very careful. When I see x plus 3, I'm thinking, oh, that's going to move to the right 3. But the truth is, my question is, what is going to keep the y value, the old y value, the same? And the answer is, I have to plug in something that's 3 less. So I actually have to shift left 3. I know that's a little tricky, but it's just something you're going to have to work on remembering. Horizontal transformations always have to do the opposite of what it looks like, or you're not going to get the same y value. So shift to the left 3, and then the -1 outside the parentheses, so that's applying to the entire function. That's shifting your y values, and y values do not do things counterintuitively. That really will just subtract 1 from your y, so that's a shift down 1. Okay, so for x's, I'm going to subtract 3 from my x-coordinate, and I'm going to subtract 1 from my y-coordinate. So let's follow the same points, 2, 2, 7, 2, 5, 4, and 3, 4. So always kind of look for those key points. If you have corners or little maximums or minimums or endpoints, those are great things to follow. All right, if I go left 3 and down 1, this is a great pair as you get comfortable to try and do together. So I will sketch in each step, but I think you could probably follow those points left 3 and down 1 without doing 2 steps. Okay, so first one, if I start at 2, 2 and I shift to the left 3, I'm going to end up at -1, 2. 7, 2, the open circle, if I shift left 3, will end up at 4, 2. 3, 4 will end up at 0, 4. And 5, 4 will end up at 2, 4. So those are my points. I'm not going to label every one this time because they end up really nicely on grid lines. So that is step number 1. Step number 2, And again, I'm doing the shift left first, the shift down second, but it doesn't actually matter what order you do shifts in. The only thing that matters is that you always shift after you do all the other transformations. So now I'm going to take each point and I'm going to shift it down 1. So the point -1, 2 will end up down at -1, 1. The point, let's do the corner next. So 0, 4 shifts down to 0, 3. The next corner is 2, 4, and it shifts down to 2, 3. I'm having to think carefully so I don't switch my X and Y. And then last one, what is that? 4, 2 shifts down to 4, 1. So we subtract 1 from each Y value, and I wasn't being careful as warned. My open circle looks like it turned into a closed circle, so that should be open, as should the last point that I did for the final graph. Okay, and the basic shape, this is why it's a parent function, the basic shape should stay the same, so it should still be straight line segments connecting the dots. It should relate to the original graph you're starting with. You're just moving it around. So there's kind of this point by point thing that we do very precisely. And then there's this general idea of, I know what this looked like. It was kind of this upside down, I don't know what that is, trough is what it looks like to me because of a calculus problem. And it should still be that same shape, just moved around a little bit. Okay, last question here is actually reversing this. It's looking at a graph and we're still relating back to the same function g. So we're looking at this blue graph over here and we're saying, what would I have to do to that graph to turn it into this new function in part C? So when I'm looking at that, one thing that jumps out at me right away is it looks like it's flipped upside down. To make that open up instead of open down, I'd have to do a vertical flip. It does not look like it's got a horizontal flip, and the reason for that is because, the reason I can say that fairly confidently is because the open circle and closed circle did not switch sides. A horizontal flip would flip-flop those two as well. So I definitely think I need a flip upside down. So let's see here. To flip upside down, you have to multiply your Y values by a negative. So that's a negative out in front. So it's going to be a negative G. And we'll see if we need anything else. But that's the first thing I think I need. Next, it looks taller to me. So the original graph was only 2 units tall. And this can be hard for people to spot because they'll want to go down to the axis and say, okay, the top was at 4 and now the top is at -4. So we didn't stretch, but it's not really about that because we can move things all around. What happened was my graph was only 2 units tall and now it's 4 units tall. So I think I had a vertical stretch happen as well. It's twice as tall. I need to double my Y values. So this should be a -2. Okay, let's look at X values as well. This was, where did we go? 2 to 7, 5 units wide. This one goes from 0 to 5, so it's still 5 units wide. I don't think I had any horizontal stretch or compression. Last thing I need to think about is shifting, and I think one of those is fairly easy to spot. My X values used to be from 2 to 7, now they're 0 to 5, so I think I shifted to the left 2 units. To make a graph shift to the left, you have to add 2 to its X values. The trickiest one here is I think there was actually vertical shift in this one, but again, sometimes people will see that the top of the graph was at 4 and then it flipped upside down and now the bottom is at -4 and they won't think they need to shift. But the truth is, if we took this original function and we flipped it upside down, it would look like this. That's flipped upside down. Then if we did vertical stretch, it would double all of those Y values. So it would be way down here. The -2s would end up at -4. And the horizontal part at Y equals -4 would end up way down at Y equals -8. So these are at -8 down here. So if we want that to hit the x-axis and then we want the bottom to be at -4, we actually have to shift up 4. So this thing needs to go up 4 to line up with our final graph there. So these can be a little tricky, so play around, but I think it's really good practice trying to figure out what those transformations are. If this is in terms of one of our basic functions like y equals x squared or y equals x cubed, you can also play around with Desmos to match up with that graph, but I think this is a really good challenge to try and work on it without being able to check in Desmos. All right, I think that's it for this one. Thanks for watching.